Hello and welcome to another Dauntless Development video. Now, today I'm going to be looking at some comments that I've had on two of my most viewed videos and kind of addressing what they say, because I've had some reasonable criticism and I think it's worth revisiting what I've said in the past to kind of correct perhaps mistakes, and also just respond to some of the things that I think might not be right. So let's dive straight into this. So, looking at this comment right here from Unregular Dude. It was a little while ago. This is from the C# plus C++ video, I believe. If I find it. Yeah. So this is from the C# plus C++ video. So, yeah, you are not too late. Definitely not. If you think when I started at university, I was 18, and that's basically the start of my path. So yeah, I mean, I I would definitely say no, you are not at all too late to the show. You could probably learn, if you did it in your own time without a university or anything like that, you could probably pick up the basics of scripting, especially if you hired like a tutor or something like that. You could probably get the basics all together in about 6 months, honestly. So you are definitely not too late. Although I would recommend getting a formal education just because it looks great for employers if you have something like that. So, Daniel Davis. Um, yeah, you're right. I replied to this and I did tell him he was right. Should have thrown code examples in there. Don't know why I didn't. It makes sense when you're comparing C# versus C++ to kind of show some of the differences. So now, 2 months later, I have prepared just a very, very simple bit of code to show you like the difference between a very simple process from one language to the other. So, just take a look back here. We have a C# script. And in this script, we are simply sending a message. So we're typing in a message into the console, and that message is then being printed by a message class. So we have the message class here. So it's inside a namespace, which you'll often see in C#. Not necessarily when you're using Unity, you don't have to use namespaces all the time, although you will be using other namespaces. You don't necessarily have to make your own. But when you're writing normal C#, you pretty much always need namespaces. So you'll see I've got public class message, and then in here I've got private string called message, and I've just initialized it to be empty. Public void send message, and this takes an input of a string, and then that assigns the message variable here up to be equal to the input, and then it calls print message, and print message is a private void function that simply writes to the console message is, and then inputs the message. So that's kind of what it looks like. And then on this end, in the main function, which you're always going to have no matter what programming language, I create a message by saying message m equals new message by calling the constructor. Then I say console.writeLine, please type a message. So that's just a prompt for the user. Then I say m.send message and then console.readLine. So that reads the line that's been typed in, and then passes it through as a string. And then I just say write line, thank you. So this will read whatever you send and print it out. So if I run this, it's a little bit small. See if I can zoom in a bit. I should have zoomed in without doing that. Okay. So please type a message. So I'll just say, hello, YouTube. And then message is, hello, YouTube. Thank you. please press any key. That's just C sharp. So yeah, so that is the program in C sharp. So C++. So you'll see immediately there is quite a difference. So there is that namespace isn't here, although you can use namespaces in C++. It's just it's integral in C sharp, and in C++ you tend to use these includes for everything, and this is integral. So what we've got here is we're including IO stream, so this allows us to input and output information to the console, and we're including our message header file, so that is the class for message, and we're including strings so we can use strings. Now you'll notice immediately, instead of what we had in C sharp, where we have our main file and then the message class file, we have two files for the message. So I mentioned this in the C++ versus C sharp video, that you have a combination of a CPP and a header file. So the header file stores like declarations of variables and declarations of functions in it. So you need this paired with the CPP file. So in the header file, you'll see I've got class message, and then I do public colon, and everything under here is public. So this is the constructor, and this is the deconstructor. So I create a void send message with std, which is standard library string called m, and you'll see this is kind of similar to how I have this string m here, send message public void, but instead of the public being here, it's up here. So it's basically the same thing. And then I've got private down here with string message, and I initialize it to be empty, and void print message, which, as I said, is kind of similar to this. So private string message and private void print message. Now, obviously, in the C sharp, we have all the functionality in the same file. When it comes to C++, we have our separate CPP files. So in here, we have to include the header, otherwise we don't have access to the function declarations. And you'll see we've got the constructor and the deconstructor. We've got void message colon colon. So this has to be, so this says we're calling the function from the message class. So this is the declaration of the function from the message class. So you have to say this. Send message, we pass in this string, so this has got the same layout as that, same inputs. And then in here, it's message equals m, print message, which is exactly the same as what it is in here. Same code. And then for print message, we say std cout, and then I can't remember what that's called, but yeah, we have the arrows pointing that way. Basically, it means output. So it's like outputting to an outstream. So we say message is, and by the way, this \n just means make a new line. So message is colon and then message, and that's how that's kind of structured. So it's kind of very similar, and then obviously in here we create our message, but we don't use the new because we don't need to. We cout here, which is just like console write line, and also to note, we include message.h because we have to include that class in order to use it. So please type a message. We create a string and then std cin s. So that's the equivalent of saying send console.readline. So this will return a string, but in the CPP, we have to basically say take whatever's typed and put it onto that string. So we have to make a string in advance, which is fine. In fact, we might be able to restructure it a different way, but this is typically how you might see it. And then we say m.sendMessage, and we pass in that string, and then we cout thank you. So it works effectively the same. So you'll see this, and I'll just say hello YouTube, and you see the exact same thing. So if I go back to the C# one, and I just zoom in again, hello, oops, let's keep it the same, YouTube. So what we can see is these are basically identical. You can get the exact same results with obviously both languages, but obviously there's a lot less in the C# one than there is in the C++. But that's just kind of a little short example, just because you were correct, Daniel. I should have thrown some code examples in there when I'm talking about the differences between the languages. So there you can see kind of some of the differences. So there's a lot more work goes into a CPP, C++ class. But I wouldn't necessarily say it's a lot harder. It just takes a lot more typing. But that extra work doesn't necessarily translate into more difficulty. It's just more work. But there are a lot of benefits associated with it, so it's not the end of the world. Okay, so this one from Ricardo D. Not very. It doesn't really come up with a reason why they think I'm wrong. But I will concede that it could be mostly personal preference. However, to my knowledge and in my experience, most of the bottleneck in terms of performance when you're running, when you're doing networking code, is not the speed of the code, it's the speed of your connection. And you don't necessarily need the kind of memory optimizations that you get from using a lower level language like C++ when you're working with networking stuff. Most of what you need when you're working with networking stuff is multi-threading and having things run in parallel. That's the most important thing when it comes to networking, not necessarily memory management, which is why I said C#'s maybe a bit better. Doesn't necessarily mean it runs faster. I just mean it's quicker to get the result. And since you don't really feel the benefit from C++, I think if you just don't, if you're just doing a networking thing, I don't see the point in putting the extra work into C++, unless, of course, you don't know C# and you're just a C++ developer. But yeah, that's where I was coming from with that. It's not that necessarily C++ is bad for it at all. It's just it takes a bit extra work, and I don't feel like you gain a huge amount from it. That's all. Okay, so here's a bit of a longer one. The gist here is they've picked up on the fact that I put in the video that when you're using C++, you need to manually manage memory, which I will admit is not entirely correct. So you don't have to manage memory. You can use smart pointers, which will handle most of the memory management for you, and a lot of the garbage collection can be done by yourself, by itself. However, smart pointers are a whole other level of kind of obstacle in itself. So if you were a beginner learning, smart pointers can kind of look a bit daunting, I find. I found a lot of people, when they see it, they kind of panic. It's not a thing that people tend to pick up very easily. However, obviously, if you do learn it and you pick it up, you don't need to necessarily worry about memory too much. So you're correct. You don't necessarily need to manage memory. However, if you're using C++, you should know how to, because you should know what to do in the case where you have not used a smart pointer. Maybe, or maybe at least to know why you would use a smart pointer. I think you, as much as you maybe don't have to do it all the time, you definitely can use smart pointers. You definitely need to know how. If you have no knowledge of memory management or how it all works, you're going to run into a lot of problems and you might not necessarily know why. So Yeah, you're right. You don't need to do memory management completely by yourself. However, there is a lot of reasons to. You can still get more optimization out of doing it yourself in a lot of cases. And as I said, just having the knowledge of how it works is very useful even when you're using smart pointers. Because if you run into any problems, um, a lot of C++, the way things work, make a lot more sense when you know why because of the memory management. Even when you're using smart pointers, when you have to declare the sizes of these pointers and stuff like that, yeah, they'll garbage collect themselves, but it's still useful to know about how the memory all works. And as I said, know the sizes of things. But yeah, as I said, you are correct. You don't necessarily need to 100%. Okay. And so this one, if you program in C++ in UE4, you should be reading the source, not the docs. I guess, yeah, you are correct somewhat in that the best thing to do is to read the source because the docs are awful. The documentation for for Unreal C++ is terrible, and is what puts a lot of people off using it. It certainly puts me off using it. Um, Now, looking at the source for things is not necessarily easy to find the answer to your question. For example, like if you know roughly what you want to do, and you know kind of roughly the area it's in, it's far easier to find it by searching documentation for something than it is to know exactly which class contains exactly what you're looking for. Um, if you know what you're doing, if you know what you're trying to use, and you just know, you just don't know how it works perfectly, or you're having a problem with something you're not quite sure why it's not working, then yeah, using the source, it can be useful because it can give you a lot of explanation as to why things aren't working as they should. And that's a very powerful thing to have access to the source. However, documentation is still incredibly important because it's written in a way that's kind of supposed to be read by a human, typically, and rather than written for just the programmer who wrote it. Because I think a lot of the time, documentation, um, when you're reading source code, even at a very professional level, code commenting is not that good. Um, and things aren't explained as well as they could be, especially not as well as they would be in proper documentation, where they might have examples of how things are used and like perhaps example code and like descriptions of every variable, exactly what they mean in plain English. So yeah, obviously you are right, but only you are right. You should use the source, but the only reason I would say you're right is because the docs are terrible. I wouldn't say that's an excuse for the docs to be terrible. Uh, I think the Unreal should really work on the documentation, especially for attracting any kind of indie devs. It's really not welcoming for somebody who's a relatively newer programmer to have to dive straight into source code in a professional level product, like a AAA kind of product. All that code's going to look totally alien to somebody who's relatively new, and people who are going to be trying to learn are going to want some kind of documentation. So yeah, I would say it still definitely needs working on. And the final one um, is from Ronnie43, who says in the C sharp versus C++, choose C. Um, Now, no, uh, no. C is a language that works for things. I wouldn't use it beyond simple electronics. It's not that. Basically, like C++, um, C++ is the closest to C out of the two. And C++ is called C++ because it's an iteration on C. It's kind of almost like a little programming joke because plus plus means add one, like iterate, and it's the next step of C. So basically, C has like a handful of functions and like useful and things that are pre-built in. And C++ is constantly being developed and upgraded and has countless tools and functions that you can use, libraries that do not exist in C. Good luck trying to program a game in C these days. There's a reason nobody does it, and I get this is probably a joke, almost definitely a joke. I'm not taking this seriously, but yeah, not C. But yeah, that's the last one for the day. I thought this would be useful because some things are easier to explain, with your voice rather than typing back in a comment, and especially for people who like Daniel who wanted to look at code examples. It made sense to do this. So anyway, that's all for today. So thanks for watching, and I'll see you next time.